All right, today we're going to tackle a really interesting engineering puzzle. It's the kind of thing that comes up every single day in these high-stakes industrial places. We're talking about a world where super fast data has to live right next to some seriously high voltage power. And well, if you get the rules wrong, the consequences can be pretty severe. So let's get right to it. Here's the core question. In an industrial setting, when is it okay for a non-conductive fiber optic cable to share an outlet box with electrical circuits that are pushing more than 750 volts? I mean, think about that. You've got this one box, and you need to run delicate fiber for communication right alongside these powerful, dangerous wires. Can you even do that? And if so, what's the one condition that makes it okay? It's a huge deal for keeping data flowing and, way more importantly, keeping people safe. And listen, this isn't just some question on a test. This is a real-world headache that engineers and technicians run into all the time. In today's automated factories and power plants, the data, the brains of the operation, has to exist right next to the electrical muscle. So how do you manage that intersection without something going horribly wrong? To get to the bottom of this, let's walk through a few possible answers that, seem pretty plausible at first glance. We'll treat them like common assumptions and kind of pick them apart to see why they might not be the whole story when the stakes are this high. Okay. Possibility number one, the most straightforward approach. Just ban it, no exceptions. It's the classic better safe than sorry move. The rule would just be, nope, you can never ever mix them. On paper, it sounds like the safest possible option, right? Just eliminate the risk entirely. But here's the thing. Is a total ban actually practical in the real world? Modern industry is all about integration. You need the sensors and networks running on that fiber to be right there, next to the heavy machinery they're controlling. An absolute ban would be a logistical nightmare, and in some really complex or tight spaces, it might just be impossible. There's got to be a smarter way to do this. Okay, so if a total ban is off the table, what's next? How about a physical barrier? This idea suggests that, hey, as long as the fiber optic cables are completely wrapped up in their own non-metallic casing, it's all good. It makes sense, right? Put something solid between the data and the danger. But you've got to look at the mismatch here. On one side, you've got a plastic cover. It's a passive thing, meant to stop someone from accidentally touching a wire. But on the other side, you've got over 750 volts. That's a serious active hazard. We're talking about arc flash risk here, a literal explosion of energy. Is a simple plastic tube really going to be enough to stand up to that kind of power? The answer is no. A passive barrier just isn't enough for this level of active danger. All right, let's try another angle. What if it's not about what the cables are, but what they do? This third idea is all about logic. It says that if the power lines and the fiber cables are functionally related, meaning they're both working for the same piece of equipment, then it's okay for them to be in the same box. They're a team. But hold on a second. Let's really think about that. Just because two cables are working together, does that magically make it safe? Imagine a technician comes to work on the fiber optic line. Does the fact that it's functionally related to the high voltage line automatically mean they know the right safety procedure to shut that power down? Of course not. A shared purpose tells you nothing about a person's training or their knowledge of safety protocols. So we've shot down a few ideas, right? A total ban is impractical, a simple barrier isn't strong enough, and their function doesn't really matter for safety. So what is the answer? What is the one thing that this entire rule actually hinges on? And here it is. This is the key. The one single condition that allows that fiber and that high voltage cable to live in the same box is if they are serviced and maintained by a qualified person. Did you catch that? The solution isn't a thing. It's not a rule about placement or materials. It's about a person. Now, you might be wondering, what exactly is a qualified person? This isn't just about someone who's good with tools. The official definition is super specific. It's someone with the right training, the right skills, and, this is the most important part, the specific safety knowledge to work on or even just near live high voltage equipment. They get the risks, they know the procedures, and they're authorized to do the work safely. And this really gets to the why behind the whole rule. It's a philosophy, really. It's about putting trust in human expertise over any piece of equipment. In a situation this dynamic and this dangerous, no passive object, no plastic cover, no sign can possibly account for everything that could go wrong. You need an active, thinking, trained human brain to manage the risk in real time. So let's break it all down. This table really lays it out perfectly. An absolute ban, it's just impractical. A physical barrier? It's a passive solution for an extreme risk, so it's not enough. A functional rink? That has nothing to do with actual safety procedures. But the qualified person, they provide what none of the others can. Active, knowledgeable risk assessment, and the ability to manage a life or death situation right there on the spot.
So here's the big takeaway. The most important thing to remember is this. The rule trusts a trained human being more than it trusts a piece of plastic or a blanket no. It recognizes that in truly dangerous environments, the single most important safety device isn't a device at all. It's the judgment and expertise of the person doing the work. And that kind of leaves us with one final big question to chew on. As our world gets more and more automated, this simple rule is a really powerful reminder. It forces you to ask, when does technology hit its limit? And when does that irreplaceable expert human judgment become our most critical safety tool? It's a really important question. Thanks for sticking with me for this explainer.